Okay, this is Michael Brown. I'm back. We're going to start the presentation now. Um, if there will be a chance to pose questions at the end of my talk, that's going to be about 20 minutes, and then we'll have some questions, and that can be done in the GoToWebinar control panel. There's a question box. And also, if anybody is interested in a copy of my presentation, you can get that in the handouts box of the GoToWebinar platform. Okay, so I'm going to start. I'm Michael Brown. I am a vice president with WSP in our Earth and Environment practice. I work in the Boston office in Massachusetts, USA. I've been with WSP for 35 years and have been working as an environmental consultant for about 40 years. My background is as an environmental engineer. I mostly work on site investigation and remediation projects, as well as some other areas such as risk assessment, which is actually relevant to this discussion. And I am a licensed site professional in Massachusetts, as well as similar types of licenses in other states, including Connecticut and Ohio. So the topic of my talk is the application of risk assessment at an urban property in Worcester, Massachusetts. Now, Worcester is the second city of Massachusetts, second largest city after Boston. And the project basically involved a site that was industrial, but then was redeveloped for other purposes. So some of the issues, included there were potential risks to people who now use the property since its redevelopment, as well as neighbors. It's a fairly dense neighborhood, so there were actually residents living in very close proximity to the former industrial site. In many ways, it's a typical environmental cleanup project, but one of the things that makes it somewhat unusual, unfortunately not that unusual, but it was in the system, in the Massachusetts Waste Site Cleanup Program for over 30 years. And the reason for that is that there were various barriers to really closing it out, both technical and regulatory. So there were conditions on the site that were difficult to completely resolve, and regulations prevented the complete resolution of all the sort of requirements under the regulatory program. So we actually got involved, WSP got involved in the project just 2 years ago. And after discussion with our client, we made an effort to try to address all of these challenges that had been stopping the site from getting finally closed out. So we came up with a strategy, and now in a 2-year period, we've managed to bring the site to a point where it can be closed, and all of these issues got resolved. So that's really what I'm going to talk about in the next probably 15 minutes or so. So just to give a little bit of background on the site, so it's a 1-hectare property, and it has an old industrial building that's 5,000 square meters. It was used for industrial purposes starting about 100 years ago in 1920. During that industrial period, so it was really about 68 years, as you can see, 68-year period when industry was operating at the property. It became a tool manufacturing facility in the 1950s, and our client actually acquired it later on, more like around 1980. And then finally, the plant was closed in 1988. So after 1988, it went through a period of being an inactive site, and then it got gradually redeveloped for other uses. For a time, it was actually used as a school, and then more recently, it's been offices and retail. So different parts of the building have different owners and different uses, but the offices are now used for a social services agency. So they're basically helping local residents, mostly teenagers, with various issues. It's kind of a counseling center. So it's a pretty densely populated area. It's near downtown Worcester. So you have commercial and industrial and residential properties all kind of mixed together, very close together. Environmental work started at the property back in the 1990s, so that's 30 years ago, and a variety of work has been done. So a lot of sampling of various environmental media, as often occurs in these investigations, occurred, and various phases of remediation were done. And most of the active remediation was done back in that period, about 30 years ago. That included excavating major excavations within the building footprint of various structures. There were sumps and trenches that had been used to collect oil. That was part of the process, basically to kind of filter and clean the oil and then reuse it in the metalworking process. And those structures leaked, and that resulted in one of the main problems with the site. But those structures were removed, and some of the contaminated soil was removed as was feasible, considering that the work was being done, beneath a building. Other things included a technology called soil vapor extraction was applied in part of the site to address solvents that had been released to the soil. So that's chlorinated solvents are one of the chemicals of concern. Um, and actually a pump and treat, a groundwater extraction and treatment system was operated for a period of time, for maybe 4 or 5 years, to remove the oil that had been released to the groundwater. So the groundwater was extracted, and then it went through an oil water separator, and then it was discharged to the sanitary sewer, and the oil was disposed of off-site. Since that period of active remediation, mostly what was going on for about a 25-year period was kind of a passive approach of visiting the site on a regular basis, measuring free phase oil that was still left behind, and then recovering it as, anytime it was found, it was removed from various wells. So during this period, this 30-year period, when the site was in the Massachusetts cleanup program, it couldn't get closed because of various challenges that I'll get into. But over the last 2 years, we were able to overcome those challenges. So this is just quickly, the details aren't really important, but it shows you the layout of the site. So you have this old industrial building. You can see residences are all over the place, very close by. You have just here south of the building. I should point out that north is to the right. So south of the building here, you have a residence just a few feet away from the outside south wall of the old factory building. And in this northern part of the building, is the area where there was a lot of free phase oil as a result of the leaks through the sumps and trenches that occurred. The solvent contamination was mostly in this southeast part of the building. In both soil and groundwater samples contained trichloroethene and other related chlorinated solvents. And groundwater generally flows to the southeast, as these arrows show. This is just a photo of the front of the building, just to give you an idea of the mixed use of the neighborhoods. You have the old factory building here on the right, and then just a few feet away, you have a three-family residential building. So some of the challenges that really were responsible for this situation of the site being in the system for 30 years, first of all, you had this cutting oil that leaked through the floor, and that resulted in a layer of light non-aqueous phase liquid, or LNAPL. That's a common buzzword for anybody not familiar with it in our environmental work. So Massachusetts, like many states, had regulations that said, well, if you find this LNAPL, or free phase oil, you have to recover it, you have to remove it from the subsurface, and you're really not finished until the thickness, as measured in a well, is no more than 1.3 centimeters, or half an inch. As it turned out, it doesn't matter how many years you keep doing that. It really appears to be not feasible to get to 1/2 an inch. After 25 years of recovering oil, it still was quite common to measure thicknesses of 6 inches or more in various monitoring wells that had been installed to monitor the situation. So that was one problem. We just couldn't get down to that half-inch requirement. Another problem was that vapor intrusion had not adequately been evaluated. This is something that we identified 2 years ago when we looked at the history of the investigation. Um, there were chlorinated solvents in soil and groundwater. That that means that there's a potential for vapors of those compounds to go into the building. And also considering that there's a residence just less than 10 feet away from the industrial building, that also could be threatened with vapor intrusion. Um, Another barrier to resolving the project was a lot of contaminated soil remained beneath the building. Even though some remediation had been done, it wasn't feasible to get it all. And the concentrations of petroleum constituents and other compounds exceeded Massachusetts standards, but it wasn't feasible to meet Massachusetts standards. So again, that was a problem. And finally, just to point out, when a site is in a system, in a regulatory system for this length of time, you also have to consider that the regulations are going to change over time. In some ways, things got more flexible, which was helpful to us, and in other ways, standards got more stringent, which meant we had to be careful about making sure that all the risks were properly addressed. I'll just mention here as an aside that in all our projects, we try to meet, at WSP, we try to meet sustainable development goals. And this project in particular had a focus on the third goal of good health and well-being, given that we were trying to avoid any risks to residents in the area as well as users of the building in terms of human health risks. So there were several areas where we had to try to do something about these barriers and see if we could just finally get the site closed out. One of the biggest ones was the LNAPL situation. So this free phase oil was present under the building. It just didn't appear feasible to remove it down to the level that the regulations had required. And as I mentioned before, you know, active remediation had been done in the 1990s, actually pumping groundwater and treating it. And then since then, the oil had been passively recovered by these sort of monthly or semi-monthly visits that had been occurring for over many years to pump out, you know, just simply to recover the oil whenever it was observed. Probably, you know, there were several reasons why it was not possible to get down to the required low level of residual oil, the half-inch. The oil was it's heavy type cutting oil. It was pretty viscous. The soils are sort of a silty sand. So overall, you know, there's a lot of residual that's hard to get out of the ground. In recent years, however, there has been kind of a new view on how to address this type of a situation. And instead of simply having a blanket requirement that you must get to a certain thickness as measured in a well, it's now recognized that it makes more sense to look at the characteristics of the LNAPL and what the associated risks are, and that even if there's more than half an inch, even if there's 6 inches of LNAPL remaining in the subsurface, it might be acceptable to leave it there as long as you can ensure that it doesn't pose a risk to any of the receptors in the area, both human and as well as potentially environmental. So some of the characteristics you would look at would include the mobility of the LNAPL. In other words, is it likely to go from where it is and move to other places, especially through preferential pathways such as sewer lines and other utilities, or is it pretty much staying where it is and not going anywhere? A related one is the stability of the LNAPL. So is the area, kind of the footprint of the problem, is it getting bigger? Is it expanding over time? Or is it just staying where it is? And finally, whatever's there, even if it's stable and it's not moving, could we reasonably get it out of the ground? So that's the feasibility point of it. So Massachusetts has adopted updates to its regulations that allow this kind of an analysis to be done in lieu of 1.5 inch criterion. So we did that for this site, and really what we found is that there is mobility. The Ellen apple is mobile over very small distances. In other words, micro scale mobility, in the sense that it'll flow into a well. If you put a well into that area, you'll see oil flowing into the well. However, it's not actually moving on any macro type scale. It's not moving down any sewer lines or anything like that. So it's staying where it is. So it's not mobile. As far as the stability, we had 25 years of data showing that the same wells had Ellen apple. Wells that were very close but down gradient did not have the free phase oil. So it wasn't getting any bigger. It was very stable. And finally, we did some analyses in order to look at the feasibility of recovery. For example, there's a technique called the bail down test, which involves removing the oil from a well, and then observing how long it takes to recover. So you measure the thickness of the oil over time. Now, that time for the oil to recover could be anywhere from minutes to hours to days to weeks. So the longer it takes, the less mobile really the oil is. And in our case, it was very low mobility. It took days before the oil recovered. So that kind of supported the idea that it's very heavy stuff, and it's not the soil is not transmissive at all to this material. So it's not really feasible to recover it. So that's our conclusion. It's limited mobility, it's stable, and it's not feasible to recover it. And under the Massachusetts recent change in the regulations, that means that we don't really need to take any further action to address the Ellen apple, other than to make sure that current and future owners are aware that it's there, and that if any construction, for example, construction work were done that involved excavation in that part of the site, that the construction workers would be properly protected, and that the soil would be properly managed. Now, another area of concern was vapor intrusion, and we did some additional investigation to evaluate the potential risks. We looked at concentrations of chlorinated solvents in groundwater and soil gas, as well as indoor air. Massachusetts had adopted several years ago, more stringent standards for some of these contaminants, including TCE or trichloroethene. And so that resulted in a situation where previous assessments of this site had said, this isn't a problem, we meet the standards, and vapor intrusion we can kind of write off as an issue. But now with the more stringent standards, that was no longer true. So we collected some additional field data, and the results actually indicated there might be a problem. We had levels in groundwater and soil gas were high enough to indicate that theoretically there could be vapor intrusion. The indoor air samples themselves, which are the most direct measure of a possible problem, had very trace levels, but we had to see through the risk assessment that I'll talk about in a minute, whether or not they were high enough to really pose a concern. And then that's just this is just an evacuated canister. That's just to give you an idea that this is the equipment that's used to collect soil gas or indoor air samples. So this is a vessel that has a vacuum, and it's opened up over a period of time. It might be 8 hours, for example, if you're taking an air sample in an industrial building, and then this canister is sent to a lab for analysis of volatile organics in air. Finally, and probably most importantly, we applied a site-specific risk assessment approach to the site. So risk assessment, very briefly, is where you look at who are the receptors. You look at all of the people, populations that might be affected by contaminants on the property. So for example, in this case, that included people working in the building, or residents who live very close by, or even construction workers that might be exposed to the soil in the future. You look at exposure pathways, which in this case, the main examples would be exposure to the soil outside the building where people could be working or walking through the site. You have the potential vapor intrusion that we talked about. And then you consider the chemicals of concern that were detected in various environmental media, in this case, chlorinated solvents, petroleum constituents, and you put it all together, considering the toxicity of these various chemicals and usually very conservative assumptions that kind of give you a worst case view of what the risks to human health might be. And in the case of this site, we were able to conclude that there's no significant risk. The trace levels in indoor air were low enough that it really was not significant at all. And same with soil. Even though a lot of residual contamination remained, it didn't represent a human health risk. There is a potential future risk, interestingly, because with the high levels that we found of chlorinated solvents in the soil gas, there's a possibility that those high levels, could migrate into the indoor air, even though we didn't find it in the indoor air. In the future, let's suppose the condition of the floor deteriorated, of the plants of the building slab, or some future owner made a hole in the floor, or there was some construction work where the floor was broken through but not properly sealed. So there are plans to we do have plans to impose some restrictions, deed restrictions that would ensure that the proper procedures would be followed under those scenarios so that the risk remains low. So in conclusion, here was a site that was seemingly kind of a run-of-the-mill investigation and remediation project, but yet it just remained in the Massachusetts waste site cleanup program for a very long time, over 30 years, because of barriers that involved the presence of free phase oil in the subsurface, residual contaminated soil under the building that wasn't feasible to clean up but exceeded standards, potential vapor intrusion problems, and changing regulations that kind of changed what the real issues on the site were, like prominently including vapor intrusion. But we were able to apply some new approaches that have become available and recognized as being appropriate, to kind of show that the elm apple, while it's still there, it's not, it's stable, it's not moving anywhere, and it's really not feasible in any case to keep trying to recover it. And finally, we applied human health risk assessment to show that the levels of residual contamination were really did not pose a significant risk. And so at this point, we are on the cusp of closing out the site. We're negotiating with current owners to impose the deed restrictions that are needed. And in Massachusetts, it's going to be called a permanent solution, which basically means that I, as the licensed site professional, am going to sign off that the site has been, adequately investigated and cleaned up. And so that'll be the end of the project finally. So that is my what I have to say for the time being, and I'd be happy to answer any questions.
Thank you, Michael, for a fantastic presentation. So just a reminder, before moving into the Q&A period, I would like to remind attendees to enter your questions in the question box on the GoToWebinar platform, and also you can download the PDF version of the presentation from the handout box on the dashboard. I will start with the first question. Does the State Environmental Agency agree with your risk assessment approach and conclusions?
Well, I hope so, but Massachusetts has a rather interesting arrangement, which is that licensed site professionals, and there are several hundred of them in the state, are private individuals who are authorized to basically come to the conclusion or certify that a site has been adequately assessed and cleaned up. So once I submit the report with my signature and stamp, that essentially is the end. Now, the Massachusetts Department of Environmental Protection has the option to to audit the LSP's conclusions, and that's always a possibility. So in that scenario, I guess I would find out whether they agree with the approach. But of course, as an LSP, I'm obligated to follow all of the Massachusetts regulations very closely and guidance. So I fully expect that there wouldn't be an issue, and that in fact the risks are in fact not significant, and that it is appropriate to close out this site.
Thank you. Are there any remaining requirements for monitoring into the future?
There would not be any ongoing monitoring requirements. There would be some deed restrictions that would require certain procedures be followed. As I mentioned, if any construction work was done, in the future, the soil and any water would have to be handled properly because it could very well be contaminated. But as far as sampling or environmental monitoring, there would not be any need for that, no.
Thank you. There's a question here about the concentration range in groundwater, the TCE, DCE, and CV.
Yeah, historically, the concentrations had been quite high. This is just off the top of my head. There had been up to about 8,000 micrograms per liter. I think the main contaminant actually was 1,1,1 trichloroethane, and there were also levels of trichloroethene, I believe, in the hundreds of micrograms, hundreds of micrograms per liter. So as I mentioned, back in the 1990s, those levels actually met Massachusetts standards, because the site is not it's not a location where drinking water is groundwater is not used as drinking water. So really the main issue was vapor intrusion, and the vapor intrusion based standards were fairly high numbers. However, more recently, the TCE, trichloroethene standard, got much lower. It went down from 300 to down to 5 micrograms per liter. So that made those concentrations unacceptable. More recently, when we took samples in the last 2 years, the levels were pretty low. The highest was about 20 micrograms per liter of TCE, but that was still high enough that required us to do more evaluation to make sure that vapor intrusion was not a problem.
Thank you. Next question is your floor slab classified as an engineering control under the deed restriction?
Yeah, it would be. It would be an engineering control, yeah, in the sense that we assume that there's going to be a slab. In analyzing the risks, for example, we did not have to consider that a facility worker would be exposed to the soil under the building because there's a slab. So in that sense, it is an engineering control, and it does have to be maintained. And there will probably be a requirement along the lines of an annual inspection of the slab to make sure there are no cracks through which vapors could possibly come into the building. And then, if any cracks or breaches are found, they would have to be repaired.
Thank you. What is the best remedial measures for the soil problem?
Realistically, if we were going to try to clean up the soil down to either background levels or the numerical Massachusetts standards, probably the most realistic approach would simply be the old-fashioned excavation and off-site disposal. Of course, when it's beneath the building slab, sometimes you can't get it all, or it's not realistic. And so that's why we have this situation on this site where there is some residual contaminated soil under the building.
Thank you. There's a question here about potential ground improvement barriers. Could they isolate the contaminants?
Well, in a sense, I think we have that situation, that the slab itself is isolating the contaminants. And I don't think there's really any need for any beyond that, any additional barriers.
Thank you. We'll take the last question. For the indoor air sampling, how do you know whether a detected compound is related to the contamination under the building or other sources?
Yeah, that was a big issue in the analysis of the data for this site. because when you take indoor air samples, you often find many, many different compounds, and sometimes at significant concentrations. And some of those compounds may not be the same ones that you expected to find based on what your main contaminants of concern were in the groundwater or in the soil. And so you really have to look at several things. First of all, a lot of things that you find might be background contaminants. So for that reason, we always take outdoor air samples at the same time as the indoor air samples. And several of the things we detected were in fact background. You also have to look at what materials are stored in the building. So you may find stuff in the air that's simply because of off-gassing of stored materials in the building. It's certainly very common in an industrial setting, and even in a commercial setting or residential. The basement of the adjacent residence had many containers of paint and paint thinner and cleaning solvents and that sort of thing that we had to consider when we looked at the results. We ended up concluding that there were really 5 main chlorinated volatile organic compounds that really were related to the subsurface contamination, and most of the rest, everything else we detected, was really just either background or materials that are stored inside the building.
Thank you. Thank you, Michael. So we're at the end of our webinar session. Thank you for your time. Please feel free to follow up directly with Michael via the contact details shown on the screen. And I would like to thank all attendees for joining today. And thank you, Michael, for a fantastic presentation.
Okay, thank you very much, everybody, for listening.